So let's start our session in object-oriented programming in C++. In one of our previous events, we had organized a beginner's workshop in C++. In that workshop, we have learned about header files, data types, variables, operators, conditionals, if-else statement, while loop, for loop, break, and continue. So, taking that further, this event will make you go through some more advanced concepts of C++, that is, object oriented programming and exception handling. So, let's continue our journey with object oriented programming. OOP stands for object oriented programming. There are two types of programming that we can implement in C++, which are procedural programming and object oriented programming. Procedural programming is about writing procedure or functions that perform operations on the data, and on the other hand, object oriented programming is about creating objects that contain both data and functions. The advantages of object oriented programming are faster and easier to execute. It takes lesser time to get executed because of its operations using objects, clear structure of programs because of classes and its structures, that is body. The whole program becomes well structured and clearly understandable. With the use of OOP, program becomes easier to maintain, modify, and debug. This generates reusable code which takes shorter development time. Let's deep dive into OOP's concepts. The first concept is object, second is class, third is inheritance, fourth is polymorphism, fifth is encapsulation, and the sixth one is abstraction. Let's see what a class and an object means. An object can be defined as an instance of a class which contains an address and takes up some memory in our system. Collection of objects is called class and it is a logical entity. For example, below you can see a class of fruits. So the objects which will be belonging inside that class fruits are apple, banana and mango. This example tells that the fruit names are the objects of class named fruits. Similarly, if we talk about functions in class, the functions which are related with the class will belong to that class, and when we create object of that class, it can be accessible to all the members of that respective classes. Let's see what a class means. A class is a user-defined blueprint or prototype from which objects are created. It represents the set of properties or methods that are common to all objects of one type. For example, in the right there is a code representing a class and a members inside that class. A class name box is created which is having public member variables which are double length, double width and double height. For example, height is a variable and double is its data type. A public access modifier represents that these variables can be accessed outside of the class using its objects and inheritance. In this way, a class and its members are defined. And going further for our next concept, that is object. An object can be defined as an instance of a class. An object contains an address and takes up some memory in our system. In the below code, you can see a class box has been created with a member function, simple sample function, and inside which there are two objects created for classroom, which are room 1 and room 2. And similarly, in main function of the code below, one box 1 of class box has been created. So in order to create an object of a class, we need to write class name and then object name. In object-oriented programming, we have four pillars, which are inheritance, polymorphism, abstraction, and encapsulation. With the use of these four pillars, our code becomes secured and it's clearly well structured. Let's see what inheritance is all about in C++. Inheritance is the procedure in which one class inherits the attributes and methods of another class. In inheritance, the class whose properties and methods are inherited is known as the parent class. The class that inherits the properties from the parent class is the child class. Also, a child class can have its own properties along with the parent class properties. So, the example that will depict the inheritance is in the right, where you can see there are two classes, one is animal and another one is dog. In dog, there is only one member function bark, with, but the dog also needs the properties of the class animal, as a dog is an animal too. And, and hence, here we require inheritance. Here, animal class will be base or parent class, and dog will be the derived or child class. Class dog can inherit the properties of parent class animal, that is its member function, which are eat and sleep. In this way, the inheritance in OOP works. Now, going further, why do we require inheritance? For this, there is an example shown here which has two classes, class X and class Y. In class X, there are two members A and B. In class Y, there are three members A, B, and C. Both the classes have two common members A and B. So why do we require extra space in class Y? If class Y can inherit the properties from the class X, so why do we need the members A, B, and C in class Y? In order to do this, inheritance comes, which abstract the common features and put them in the base class. From base class, the derived class can inherit the properties and also can have its own properties. So that is why we require inheritance. Going further to the implementation part, how are we going to implement inheritance in C++? The syntax is class name, then colon, and then access mode followed by the parent class name to define the inheritance for a class. There is one example in the right for inheritance. You can see one class parent and another class child. Here, child class is inheriting from base class parent. So inside main, an object of only child class is declared, and using only that object, we have defined IDC and IDP values, which are 7 and 91. And in the output, we will get child ID that is 7 and parent ID that is 7 and child ID as child ID as 7 and parent ID as 91 according to the parent and child classes. If you have any doubt in this particular part of inheritance, you can ask or you can put your questions in the chat box. If you have any question in the implementation of the inheritance part. Okay, so if no questions are there, we'll move further for the polymorphism. That is the another pillar. The word polymorphism means having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. For example, that is displayed here. A man at the same time is a father, a husband, a brother, and an employee. So the same person possesses different behavior in different situations. This is called polymorphism. Polymorphism, in the right you can see there is a hierarchy showing polymorphism is divided into two parts, that is compile time and runtime. In compile time there are function overloading and operator overloading. Runtime consists of virtual functions. Let's see what a compile time polymorphism is. Compile time polymorphism takes place during compilation. It is achieved by function overloading and operator overloading. What is function overloading? Function overloading takes place when there are multiple functions with same name but different parameters. Then these functions are said to be overloaded. Functions can be overloaded by change in number of arguments or change in types of arguments. Next comes operator overloading. Operator overloading in C++ provide option to overload operators. For example, we can make the plus operator for string class to concatenate two strings. Plus operation can be worked on the objects as well. It's up to us how we are defining the plus function overloading. Next, we have some examples of compile time polymorphism. In the first code, function overloading takes place. There are two functions with same name display value and with same number of parameter, that is 1. But in both of them, the data type of the parameters are different. The first function parameter is having int as its data type, and in the second one, string is the data type. So at the time of function calling, the first function call is providing Swift as a value, which is a string, in which the second function with string parameter will be called and then will get executed. In case of second function call, it's an int value, so the first function will get executed. This is how the polymorphism takes place. The right one is an example of operator overloading. Here, for addition, that is plus sign operator will be overloaded, which is being defined for objects. So, in the class complex, there is a function created, which is a syntax to write code for operator overloading. In this function, a function will be called when we need to add two objects and not two values. When we add two objects that are defined below, this function will be called. In the main, complex 1 and complex 2, which are objects of complex class, are being added with plus symbol. So here the operator will be overloaded and the addition operator function of the above class will be called. Going further for the runtime polymorphism is achieved with function overriding, which occurs when a derived class has a definition for one of the member functions of the base class. That base function is said to be overridden. In the right, there is a code in which there are two classes. The class derived is inheriting the properties of class base. In derived class, there is a member function print, which is called print function of class base. So, when we will define derived class object in main, it will firstly call derived class print function and then will call base class print function. In this way, the function print is being overridden in the code. This is all about polymorphism. If you have any question related to polymorphism, you can ask.
Please be active, show some interest.
If you are new to these topics, you should have some questions. This will be to implement in C++. So please ask some questions.
Nitya, there are some questions in the chat section. You can have.
Nitya, did you read the question?
Yes, I got one question, that is polymorphism applications.
Yeah.
So you can use polymorphism in case you want to have multiple functions and all those things, and you can implement this in order to make your program object oriented. That is more clarity of the program, and it will take lesser time to get executed if there are multiple functions that you have created and you have multiple classes. So in with the use of polymorphism, there are lesser time, it will take lesser time to get executed, so it would be helpful.
Like it depends upon your application. Like if you're building any console application, so according to that, you can use polymorphism. Suppose we have runtime polymorphism and example code, like we are using function over. So you can override the function of your base class, the child class, and it completely depends on what application you are building and how you need to use the
Yes,
polymorphism
and
here.
if you want to use compile time polymorphism, and there are multiple functions, so in your code it would be simply identified if you have given different parameters or data type count. Like you can see here, there are int and string values. So you can create multiple functions with the same display value. You can have multiple parameters here, for example, int and string, you can put it together. So these display value can help you program multiple functions. Any other questions?
Nitya,
Uh,
have you stopped the sharing?
no.
Okay, I cannot see your screen. Can you reshare?
Yeah, sure. Can you see that now?
Yeah, I can.
So, any other question? Or shall we go ahead?
I think we can move ahead.
Okay. So, over to you, Muskan.
Yeah. So next slide. Yeah. So as Nitya told you that we have four basic pillars in object-oriented programming, which are inheritance, polymorphism, abstraction, and encapsulation. So before going further for abstraction and encapsulation, we need to know what are access specifiers. So we have three types of access specifiers, that is public, private, and protected. So uh, I think that the screen is again stopped.
Heard from my side. Yash, can you verify if you can see the screen or not? Okay, it's not visible. Can you see it, Muskan?
No, I think there's some problem at my end, maybe.
Yash, can you see the screen?
If everyone can see, like,
Okay, fine.
so, so you're on the access specifier slide, right?
Yes, right.
Okay. So, talking about access specifiers, we have public, private, and protected. And what does the public access specifier means? That is, it is accessible to outside world. Like the public word resembles this. It is accessible everywhere. And talking about private, so it is not accessible outside. It's only limited to its own space. That is private. And third one is protected, so it is accessible to the derived classes. That is what we learned about inheritance. We have base class and derived classes. So the protected member variables of the base class can only be accessible to their child classes or their subclasses and not outside the world. So these are the three kinds of access specifiers, and by default all the data members and member functions are made private by the compiler. Now coming to the next slide. Are you on the next slide? Yeah.
Huh.
So talking about abstraction. So what is abstraction in C++? So data abstraction is one of the most essential and important feature of OOPS. And abstraction means simply like displaying only essential information and hiding the details. So for taking an example, like if a man is driving a car, so he only knows about uh, where is the brake and how to use it, like uh, and how to use the accelerator, but he does not knows the inner mechanism of the car, like how the accelerator and how the brakes are implemented. So this is what that only the useful information for the user is made visible to them, and all the extra details are hidden from the user. Now coming to the next slide. So are you on the next slide, Nitya? You can confirm me.
Yes, I'm in the next slide.
Okay. So talking about abstraction in C++, so we have three kinds of abstraction. Like first is abstraction using classes. So we can implement abstraction using classes, and classes helps us to group data members and member functions using available access specifiers, that is private, public, and protected. So a class can decide which data member will be visible to outside world and which is not. This is done with the help of access specifiers. So we can see an example here. We have a class abstraction example, and it has its private member variables, which is int, num, and char ch, and we have some public functions. So we have set my value function member function as public, and void get my values as public. So these are the getter and setter functions, and we have just like we can see, by making these data members private, we have hidden them from outside world, so the user does not knows what are the variables in the private. Then here are the in public function, we have num equals to n and ch equals to c. So these members are not accessible outside the class, and get my values also. So here we have the only way to set and get their values is through the public functions. We cannot access the variables num and ch outside the class in the int main function, but we can access the variables n and c, which is in the function set my values and get my values in the from the outside the class, that is using the int main function, because these are made public using the access specifier. Now coming to the next slide. So we have abstraction in header files. So what we understood from abstraction, that is we are just hiding the extra details, and we are just making visible information for the user. So we have header files at the top of the file. For example, we are considering the method present in the math.h header file. So we include math file at the top of our file, and we directly call the function power present in the math.h header file by passing the numbers as arguments, and but we don't know what algorithm is used in that power function, like, because that is included privately in the math.h. We only know that we have included a file math.h, and we have this power function, so we are directly calling that function and using, but we don't know what is inside that power function, what algorithm is used and how it is made. So this is abstraction, like we are only making visible the useful information and hiding the extra details, or hiding the information which is not relevant to the user. Now coming to the next. So we have abstraction using access specifiers. This is the basic part. Like, access specifiers are the main pillar of implementing abstraction in C++, and we can use access specifiers to enforce restrictions on class members. For example, members declared as public in a class can be accessed from anywhere in the program. Like I said, from int main function. So the public members can be used anywhere, and members declared as private in a class can be accessed only within the class. They are not allowed to be accessed from any part of the code outside the class. If I've declared a member private member in a particular class, so I member in that class itself, not outside that class. Now coming to the next part. Yeah. So advantages of data abstraction. So it helps the user to avoid writing the low level code, and it avoids code duplication and increases reusability, and can change internal implementation of class independently without affecting the user, because we are not showing user what are the things which are private in the function, and we can directly modify those things internally and user would not be affected by that. Then helps to increase security of an application or program, as only important details are provided to the user. So this is the main part of the abstraction, like only the important details are provided to the user and all the extra details are hidden from the user. Now coming to the
Muskan,
next.
1 second.
Yeah. Okay, so I think I should share the screen. Nothing, you can stop sharing. Nitya, can you confirm screen is visible?
It is visible.
Okay. So should I take back the topic abstraction or it is fine?
Maybe last slide you can take again.
Okay. So I was talking about the advantages of data abstraction. So what we read is it helps the user to avoid writing the low level code. Then it avoids the code duplication and increases reusability, because we declare the private member variables in class, and then to access them we create some getter setter functions which are made public or protected, and we can call those functions later in our code. So this increases the reusability. Then we can change internal implementation of class independently without affecting the user. So what I told is that since we are only showing some important information to the user and hiding other implementation of the class, so we can change the, or we can modify the functions or its implementation, and the user would not be affected from that. And next, it helps to increase the security of an application or program, as only important details are provided to the user and our internal functioning is hidden from the users. So this increases the security. Now coming to the next topic. You can see the slides, right, Nitya?
Yes,
You can see the encapsulation slide,
yes,
right?
yes, yes, I can see.
Okay. So coming to the next topic, which is encapsulation in C++. So when all the data members and member functions are combined in a single unit called class, this process is called as encapsulation. Like we have a class and we have some variables in that class and some methods. So the variables and the methods which are manipulating those variables, when they are combined in a single unit which is known as a class, this process is known as encapsulation. Like we are combining the uh, related member variables and functions together. So encapsulation also leads to data hiding or abstraction. So using encapsulation, like it leads to data hiding and abstraction, which we studied just now. So, encapsulation is a means of data hiding. Then it binds together code and data it manipulates and keeps both safe from outside interference. Like as we learned, we cannot modify things which are private from outside the class. So it keeps the data and functions safe and safe from the outside interference. Then it tells exactly what user can access and cannot access through public and private access specifiers. So when we are using public and private access specifiers, the user can easily know like which variable of which function they can use from outside the class and which they cannot access. To the next, how to implement encapsulation. So we can implement encapsulation using the access specifiers, which is encapsulation in data heading. So we can see the capsule shape here. So we have some member variables and functions here which are private and which are public in encapsulated in a class. So we have combined those member variables and functions in a class, and we have some private member variables and functions which are restricted access from the outside class, and some of them are public which can be accessed anywhere through class object.
Can't,
Yeah.
we can't see your screen.
Okay, so it's still not visible.
No,
It's visible on my end.
Like it's fluctuating maybe.
maybe. Okay, you can continue.
Okay. Can two people share at same time? Is it so?
You can start now.
Okay, is it visible?
Yes, yes, it is visible.
Okay. So we are talking about how to implement encapsulation. So we can do this using access specifiers. Here we can see this capsule in which we have some private member variables and functions, and some are public. So private cannot be accessed outside the class. They have these restrictions, and public can be accessed anywhere through the class objects. So this is how we implement encapsulation. Now coming to the example, so suppose we have a class student here and we have a private member variable which is int age, and we have the public function which is void set data and int get data. So here in the top part, which is private int age, we are hiding this data because this is private and the user cannot see this data, and the user doesn't know about this age variable. So this is the data hiding part. And here we have public function set data and get data. So set data is setter, which is like, what is setter? We are using another variable which is maybe public to change the values of our private variables. So we have this public function set data, and we have the parameter in student age. So our student age is the public variable, and we are modifying the value of our private member variable, which is age, using the student age. So age equals to student age. So we are not directly changing the age variable, which is private. And then we have int get data, so it is getter function. So we are using this to get the value of our private member variable, which is age. So we are just simply returning age. And so these are the setter and getters, and get and set methods are used to read or modify private data. So here comes the abstraction and data hiding part. And what this part is, in we have a class student and we have some private member variables and some public functions and member variables. So this is, we are encapsulating some of the data members and functions in a class. Now coming to the next topic, is it visible?
Yes.
Exception handling in C++. So simply, what is exception handling? If we see, like in programming, it is normal to commit mistakes that leads to errors. So there are three kinds of errors. First is syntax error, second is logical error, and third is runtime error. So we have, like, first of all, problems occurs and then it creates exception, then it throws exception, and then it handles exception. So we will learn what is this about. So to tackle these runtime errors, we have concept like exception handling. Now, what are the building blocks for exception handling? So we have first as try block, the second is catch block, and the third one is throw statement. So these are the three things which we need to use and understand in order to implement exception handling. So coming further, what is the try block? So the try keyword means we are going to try something even though we are not sure it is going to perform correctly. Like we know that something might go wrong here, but we want to try, like, if something goes correct. So we are just from the particular part of the code where we are unsure that it can work correctly or not, so we'll keep that particular code in the try block where we are unsure. Then we have the next statement, which is throw keyword. So the throw keyword is used when we encounter an error and means we are going to throw two things. First is a value explicitly, and second is control flow implicitly. So when we face runtime errors in our code, it generates an exception error and it stops the code from working further. So it just ends the execution of the code there itself. And why we use exception handling? To stop that, like, we don't want to stop the execution of the code suddenly, and we want it to behave in a specific manner if something goes wrong. So this is why we use exception handling. So when we use the try block in the code where we are unsure, we have something like throw keyword, because if any error is encountered, so we use the throw keyword and it will tell the compiler where to go next if the error occurs. Then we have the catch keyword, and the catch keyword means we are going to try to catch at most one value. So to catch different types of values, which are different type of errors, we need multiple catch statements. Suppose we have to catch the int value or string value. So if different data types are there, so we need multiple catch statements there. So we can see here we have a try block, and this block finds errors and throws or executes an exception. And in the try block itself, we include this throw block. So wherever we think we might get an error, we use the throw statement there. If any error occurs, then throw this to the catch block. Whenever we use the throw statement, it throws the exception to the catch block. So now in catch block, we have, it gathers the exceptions from the try block. So what is try used for? It checks whether everything is working fine or not, and if any error occurs, it uses the throw block to notify the catch block, and then catch block gathers all the exceptions from the try block and it notifies the users like this particular error or this particular exception has been occurred, and it follows the particular control flow which is mentioned. So we should see an example for this. So we have a code here, like we have the int main function and we have a try block here. We have int age equals to 15, and we have if age greater than equals to 18, so it should print access granted, you are old enough. So this is about the age limit. If you are greater than or equals to 18, then only you should be granted the access, otherwise it should create an exception. So in the else part we have throw age. Then we have after try block is finished, we have our catch block. So it is means we are catching int my num, that is a number variable, and what is in it showing in cout access denied, you must be at least 18 years old, and it is showing age is this much my num. So how this try and catch block is behaving is, we have the variable age and its value is 15. Now we will check in the if block if the age is greater than equals to 18. So 15 is greater than equals to 18? No. So it will go in else. And in else we have the throw statement which will notify the catch block. So we have throw age. So it will the throw statement will work and it will notify the directly go the execution to the catch block. And we have int minum. So whatever the throw statement, like in the throw arguments we have the variable, the catch block will catch that particular variable. So we have a integer variable in the throw age. So here we have used in catch int minum because it is an integer value. And as soon as throw will notify to the catch block would execute and it would print access denied, you must be at least 18 years old, and age is minum, which is catched by using the catch block. So we have age is 15. So simply if the age was more than 18, so it would have executed the if block access granted, you are old enough. And if it is not satisfying the if condition, so it is going in the throw statement and then throw notifies the catch block, and we have, so this would not stop the, and we can use this exception handling where if we divide a number by 0, that is division float error. So if I'm dividing suppose 4 by 0, so this is runtime error, like 4 cannot be divided by 0, this is an exceptional case. So we can mention there are some predefined exceptions like with so this is division error. So we can see in the official page, like where we have the concepts of exceptional handling, like what all predefined exceptions are there. So we can use those exactly in the similar way to create those exceptions and handle the code flow without stopping the execution. So that's all. So thank you for your time. And if you have any questions regarding any of the concepts or any doubts, you can feel free to ask. Nitya, is my screen visible?
Is visible.
Okay. So do you have any questions regarding any of the topics we covered in the session today?
Yes, if you want us to repeat any of the topics, you can just
Yeah.
mention it in the chat box.
You can ask any doubts, or you have been trying some code in C++, but you are facing some error or something like that. You can ask, you can share your doubts. Akshat, are you there? Someone has a question like maybe get the recording. So are we going, Akshat?
Yes, we will share.
Okay.
Akshat, if no one has any questions, so can we end the event?
Yes.
Okay, so I would like to thank all the wonderful people who spoke or performed today on my behalf. It was an amazing lineup. All of you taking time out of your busy professional and personal schedules means world to us. And if anyone of you ever needs to speak to us on your behalf, you can just contact us or you can mail us. So thanks a lot, everyone. We thank you for we thank you all for being here and participating with us in this event and making our event successful. So if no one has any questions, so I think that we can wrap up this event. And again, I would like to thank Muskan and Nitya for an amazing performance in this event. Thank you all.
Thank you, Yash. And if anyone has any feedback for this session, like they can chat, they can comment in the chat, or they can mail to us. All right, then we should end the session. Thank you so much,
Thank
everyone.
you, everyone.